Hello students, welcome back to the Tantray physics classes. In last two lectures I have delivered on inertial and non-inertial frames of reference. I continue to deliver lectures on this inertial, non-inertial, centrifugal force. Possibly I will be giving lecture on also on Coriolis force. So these are the forces that are being observed from the non-inertial frames of reference, like centrifugal force, pseudo force, Coriolis force. So a few more lectures on this on inertial and non-inertial frames of reference. Today I am discussing an example where a problem is solved by an observer in the inertial frame of reference, and the same problem is solved by a person in non-inertial frame of reference. And interestingly, both will get the same answer. Let me start. Suppose it is a car. It is accelerating with acceleration a0. It's a car accelerating with acceleration a0, and there's a bob hanging like this, a pendulum like. It is hanging from the ceiling, and when it accelerates, we need a force on the bob for its own acceleration, but there are no forces on this bob in the horizontal direction, forward direction. Therefore the string will tilt backwards to produce that force, and this will be like this, and the tension now will be like this. Initially tension was vertically upwards, and that tension was not having any component in the x direction. Therefore the bob will move in the backward direction, and this will create a theta with the vertical line. We have to find how much theta will be there when the car moves in the forward direction, accelerates in the forward direction. Okay, now here is an observer. Whose velocity is 0 with respect to ground, and it is inertial frame. The observer in the inertial frame of reference. Inertial frame of reference. And I asked this observer to find this theta. Let me see how he works with it. First of all, point number 1. For him, what is the acceleration of this bob? The acceleration of this bob will be the same as the acceleration of the car, that is in the forward direction. So the acceleration, first observation, the acceleration of the bob is ax is equal to a0 and ay is equal to 0. Because there is no motion of this bob in the vertical direction. There is no acceleration in the vertical direction. This is the first observation of this observer who is in the inertial frame of reference. Now second, what are the forces that he will observe? What are the forces that he is going to observe on the object? Okay, he will observe only real forces. Those forces which have actual agents, as I have discussed in the last lecture. He will observe the force mg downwards, tension here, yes, theta here, and this is also theta. Tension will get two components upward, t cos theta, and this will be t sin theta. So there are three forces, mg, t sin theta, and t cos theta, or only two, mg and t, but t has been split into two components, and now we have three pieces of forces, t cos theta, t sin theta, mg for this person. So what are the forces? Forces is the forces acting on the object. Forces acting on the object. What are those forces? Yes, summation fx, all the force in the x direction, that is t sin theta. This one, this force. And summation fy, what's that? That's T cos theta minus mg. These are the vertical summation of the vertical forces. This minus this. This is the y direction. Okay. Now third, equations of motion. How he will write the equation of motion. Equations of motion. Sigma fx is equal to mass ma, like this. Fx, that's T sine theta, is equal to m. What is the acceleration of this object in the forward direction? That's the same as the chord, that is a0. So this is one equation that he will write, and the next equation he will write summation fy is equal to may. That is summation fy is what? T cos theta minus mg is equal to ay0. So T cos theta is equal to mg. It is equation number second. Maybe this is the equation number first. So from first and second, he will find the solution. So what is the solution? For finding theta, the angle which it makes with the vertical line, that the bob, to cause its own motion in the forward direction. So what is that? How that can be done? So I divide fourth solution. That is T sine theta is equal to ma0 and T cos theta is equal to mg. You just divide them. When we divide them, what we get? We get this cancels, and this get tan theta is equal to, this goes ag by a0 by g, and theta is equal to tan inverse a0 by g. That is all. So this is the solution by an observer who is in the inertial frame of reference. Lucid, clear and simple. He will just write down the real forces, and all those real forces will create the object, the acceleration in the x direction, that is a0. And there is no net force in the y direction, and he has wrote these equations and he got the answer. Okay, let me solve the problem from the non-inertial frame of reference position. Okay, non-inertial frame of reference. Same problem, but now the observer is where? He is in the non-inertial frame of reference. The person is also in a system which is accelerating, and better is to put him in the same system, in the same car, and let him solve the problem inside the car, but he must get the same answer. You can't get a different answer by different observers. All the observers from all the frames of reference should give you the same answer. Okay. Now second point. Again the same cord is here, accelerating with a0, and here is a pendulum. Here is a pendulum, and it goes like this. Because of the acceleration, it has to create a forward force. Okay, now let me put the person here on the car or inside the car. He is also accelerating with a0. Right, is a tension T. It is mg. Because for him also the real force are there. Whether the observer is non-inertial or inertial, the real force are for both of them. Real force are they are real, and both the observers will count these real forces. Okay, now first observation by this person who is in the car or who is on the car, the same thing. What does he observe? First of all, he observes first observation, the acceleration of the object inside the car is 0. Why? Because everything inside the car is at rest for him. Everything in the car is having 0 acceleration with respect to him, because he is himself accelerating. The relative acceleration is 0. Anything inside the car has acceleration 0 with respect to this person who is just on the car in the non-inertial frame of reference. He will observe this object has 0 acceleration. So A is equal to 0. If he says net acceleration on the object is 0, then immediately what he says that F net is 0. That's the first observation that he makes, because everything inside the car has no acceleration with respect to him, because relative acceleration A0, relative acceleration is 0. Okay. Second point. Now, what are the real forces for him? Forces observed. Forces. This is mg. He will observe this tension also is theta. This t will go two pieces. This is t sine theta, and this is, because this is theta, it is t cos theta. He will say the force is t sine theta, t cos theta, and mg, real forces. He will certainly agree with these three forces. This one is a single force, but it has been split into two parts. But in addition to that, he is in the non-inertial frame of reference. He will observe additional force, pseudo force, opposite to his own acceleration, and he will observe additional this force, mass of this object, and his acceleration A0, but this force will be opposite to his acceleration. So he is accelerating this way. He will feel that the object has additional force in the opposite direction. In the opposite direction, if his acceleration is A0, he will say, he will observe, he will feel on the object the force MA0 in the opposite direction. So this is additional force. This is the force in addition to these real forces. Is that right? Okay. Now it is mg, it is t cos theta, t sin theta, but in addition to these real forces, he will observe one more additional force on the object in the opposite direction, that is MA0. So forces, summation fx, that is t sin theta minus MA0. These two forces opposite, therefore summation fx force is this minus this. Summation fy force, that is t cos theta minus mg. This is his observation about the forces. He will measure the net force in the x direction as this. He will measure the net force in the y direction as this. But already the net force is 0. And net acceleration also 0, as observed by the person on the car or inside the car. So what he is going to write? Third, that is solution, equations of motion. What he will do, he will write sigma fx is equal to max, mass into acceleration in the x direction. That is sigma fx is t sine theta minus ma0 is equal to m into ax, that is 0. Because when net acceleration is 0, ax component is 0 and ay component is 0. That is how we learn the vectors. If a vector is 0, then all its components are individually equal to 0. Okay, now this is 0, and now what about this equation number first? Now sigma fy is equal to t cos theta there minus m g is equal to may. Now summation of fy, okay, this t cos theta minus mg is equal to again 0, ay is equal to 0. Now t cos theta is equal to mg, equation number second. Now he will use the first, that this equation and this equation to find the answer. But here we could have, okay, now You have these two equations, equation 1 and equation 2. What is equation 1? T sine theta is equal to MA0 from here. What is equation 2nd? That is T cos theta is equal to mg. Dividing the two equations, we get this will cancel. So tan theta is equal to, this will go A0 by G. Now what is theta? Tan inverse A0 by G. Again, the same answer by a person there at the top of the car or inside the car, he will get the same answer. But he will create this pseudo force for himself. But for him, the object is at rest. For the person outside, the object is accelerating. There is no this force for him, but the object is accelerating. For the person in the car, there is no net acceleration of the object because he creates a backward force ma0. That's all. So this the question was, what was the angle it can subtend? The object, this bob subtends with the vertical axis, and the question was solved by both the observers, inertial observer and non-inertial observer, and both have given you the same answer. This was I think third lecture on this inertial and non-inertial frames of reference. I am continuing with this with a few more examples so that this is clear to you. But in the meantime, you can download my app, Tantray Sir Physics Class, and continue to watch my lectures on YouTube. Thank you.